we have this Hello World C++. What were we going to do? Oh, we were going to talk low-level memory. So you get the first lesson on low-level memory. Uh,
Yes.
um, it's probably easiest to start out by talking about uh, something called the stack and the heap. Um, did I tell you guys about this? Do you remember me telling you anything about this when we were doing the original?
I do not. I feel like I would have
Um,
remembered
so the
stacking.
so the RAM, when you run an application, basically allocates a certain amount of memory to the application within the RAM itself. And uh, nominally, a lot of times it ends up being like two gigabytes or something. It depends on the application, and I'm not an expert on exactly how much it allocates, but within that chunk of like, let's say 2 gigs for one example of like 16 gig RAM, um, it kind of takes it and slices it into two pieces. And one is called the stack, and one is called the heap. And the stack is much smaller. It's kind of like a slither, and the heap is like a big chunk.
Okay.
And the stack is meant, it's where all the code that is executing all the functions, the memory for the functions and the subroutines and like, et cetera, they run on the stack. And then the heap is kind of like for like bigger memory storage while the program's running, essentially. So if you're not storing it on the hard drive to like a database, you're probably storing it within the heap. The reason that I bring that up is you usually don't know anything about that until you're working with C++.
Mhm.
Um, so if you're in C++, you have the ability to access heap memory through a thing called a pointer. And so you basically have to do it explicitly in the code, and I'll show you how to do that. But you can store stuff in the heap, and you can store
Okay.
stuff in the stack. The only difference, I bring that up as like context because I might mention that as we go through. The only difference between those is more can be stored in the heap, and things run faster in the stack. So if all your memory's in the stack and your variables are in the stack, then they run a little bit faster. If they're in the
Mhm.
heap, they run a little bit slower. You probably wouldn't notice it unless you're doing really high efficiency stuff. Um, but the heap, typically if you're trying to store stuff more like additional context outside of subroutines, you're going to end up storing it in the heap. So we'll talk about that a little bit more. But I want to give you an example of a pointer. So let's just, for the sake of this, I'm going to go ahead and comment out this, show you syntax for like multi-line comments. In C++, it is this. You do a slash and a star and a reverse star, then a slash, and it becomes a multi-line comment. Typically, someone ends up doing two. Uh, you don't have to. Okay, so we commented out all that. We will go ahead and delete our little code here. Um, and this is our main function, so it's going to run when we compile and run the program. Okay, so we want to start out by just giving you basics of what a pointer is. So um, there's kind of like everything pre C++ 2011 standard uses regular pointers. Pointers, references, and values are kind of the three different types of memory. We'll talk about it. Um, and everything post 2011 tends to use smart pointers. The high level difference between those is that regular pointers basically are riskier for the developer to mess up from a memory standpoint and break the program. Smart pointers have some fancy wrappers around the pointers to kind of help clean things up as you go so that the developer doesn't have to worry about it. We'll talk a little bit about that because with C++, you can actually kind of break memory and it's harder to program for a reason. So let's start out with the basic primitive a equals 0. And we'll do, I'll tell you what, we'll do an example here where we're C out a, we have to do std to string a inline, and I'm gonna have to do I'm gonna set it up so std. I'll explain all this in a second. What's going on here? Maybe I didn't have to do that with IOStream. Give me 1 second. Just gonna go back because I had it. I'm gonna delete all this. Okay, I did do it. I must have just spelled something wrong. I had syntax error. So okay. So let's just do int a equals 0, print out a. What am I syntactic? What do I syntactically have wrong here? Quick fix. No, I had ordered to save it. Expected a. Let's just do a quick sanity check here. Something is goofy. Do I have like a hidden character? Sometimes if you have hidden characters and stuff, it'll like break things, but is it arguing about that? It can't be. So I just do that. Expected a. Oh, it's an okay. I got it. So that was a weird error. I should have just looked at the code. To string. Okay, so C++ again is statically typed, so it requires you to specify the types and to be very specific about it. Is that actually an error? I'm gonna just throw this in a ChatGPT and say, what is my problem here? I should be better than this, but like,
That's weird.
Why is there anything wrong with this? Yes, there are a couple issues. ToString does not exist. It's to_string. There. So dumb. That's so annoying. Okay, so that was the issue. Was to_string. By the way, is this too small to see? Can you see it? Good enough?
You're good. I have it zoomed in on.
Sweet. Okay, so let's break down what's happening again. Preprocessing directives, porting in a library. Okay. In C++, there's these things called namespaces. Say namespace. Namespace. And namespaces are essentially monikers that go in front of like functions or variables and things from libraries or classes. With these two double like colons. And what it does is it allows you to have the same naming structures within different names, like higher level categories, so that if I was to, build an application that was like a car application, right? For, I'm just making this up, but for like Porsche. And I put everything inside of a namespace called Porsche. Then I exported my stuff and gave like header files and everything else to someone else. We haven't talked about header files, but I gave like the code to someone else to integrate with, right? And they also were a car company, but let's say they were the engine company, right? If I didn't put it all in the Porsche namespace, then we might have the same class named car, and there would be like a name conflict, and it wouldn't know which one to use. So if you add a namespace, which is like kind of this extra thing you tag onto it, then it knows that this is the Porsche namespace and this is the engine namespace, and it helps you deconflict different same name variables. So it's just kind of like a name deconfliction technique. The reason I bring that up is STD stands for standard. Um, and it is the namespace for the standard library that comes with C++. And so you can either specify if you're going to use a function from C++, like this library IO stream comes from the standard library, but you still have to use the namespace. You have to tell it what namespace you're in.
Mhm.
If you use it here, you're good to go. Or you can say using namespace std, and then this is irrelevant. You don't need it anymore because you're specifying the namespace you want this file to use. So it automatically knows to tag on basically std to the front of those.
Mhm.
That typically is not the best practice. It's typically best practice to specify it as you go, so that if you have multiple namespaces and multiple libraries with different namespaces in one file, your name deconflicted.
Mhm.
Okay, side tangent to explain that. This function called to_string is a function in the standard library of IO stream that can convert the integer in memory, the int, to a string in memory. So it does that, and then it sends it out to the command line. So that's what's happening there. I haven't even gotten to memory yet. I realize we're 60 minutes in, but that's like an important piece to talk about. So I'm going to go ahead and compile it and run it, and I get printout of zeros. Okay, so let's talk about memory. This whole thing is running on the stack right now. Okay, so the
Mhm.
reason it's running on the stack is I haven't specified a pointer or a reference or anything. Um, okay, so now let's change this to a pointer. The way that you do
Does it
this,
always default to stack?
yeah, it's default stack unless you specify elsewise. Okay. So what did I just do there? This fancy star symbol, it doesn't matter where you put it. You can put it there. You can put it here. Standard practice is to put it here. Although I have bad practice, so I usually put it here. Just depends on how you learn C++. That means I want you to create this variable in the heap. So assign it to the heap and assign it a value of 0. Okay. Then over here says, I want you to find A is now a value in memory. That's the first thing to know.
Mhm.
Um, and I'll break it apart into 2 lines, declare and define, just for clarity here. This declares a variable in the heap, a variable in the heap memory and the RAM. Okay.
Mhm.
This declares a variable in the or this assigns the memory address of the variable in RAM the value of 0. Now it's that 0 is converted to the binary 0, which is still 0, but it's
Mhm.
now taking a memory address that it had declared in RAM in the heap, and it now assigned that memory address to 0, right? So the memory address was
Mhm.
initially empty of values, and now we've assigned it the value of 0, right? Then we
Mhm.
come down to this line, and this little inner inside the parentheses, the first thing it does is it says, I'm going to dereference that memory to turn it into the 0. Then I'm going to convert it to a string and I'm going to put it out. Now, this should work real quick. Let's just make sure we don't have any errors. And then I'll explain segmentation fault. Can I just STD out without converting? What is happening here? Segmentation fault. So dereference that correctly, or do I have to do? Hold on. I might have my C++. Like, what would it be here? Why am I? Let me back up real quick. Just do this real quick. Interesting. Why is that working? Maybe I don't have to dereference it because it's a primitive. I don't think I have to dereference it. That might be why. Let's just do a non-primitive. So you remember how I taught you about characters and stuff back in the day? Well, in C++, you have to do if you want to do a string, std string. Oh, I didn't do double colon. That's the reason. Where is this? Something scoopy here. Oh, it just took a little bit for it to like figure itself out, I think. All right. And so now we have to do a string and we'll do test. It's a string. Okay. Does it work with capital S? No, it is lowercase s. Okay. So this says use the string type, which is not a primitive in C++. It's actually just a type class. And we'll talk about that later. But A is now equal to this test. And if we print out A, we should get the memory address and not the actual test. Why am I not getting the memory address? Oh, I didn't declare the pointer. That was my point. It was on the stack. So now it's a pointer. And I think I might need to say the value at that location is string. Okay. We're getting there. Segmentation fault. Why am I getting a segmentation fault? Hold on, I got to solve this because this is like something's happening with the pointer. It might be the type of C++ I'm using. Like there's a point where you'll print out the memory address, and there's a point where you actually print out the variable. And I wanted to kind of describe that because you have to like pointers carry the memory address; they don't actually carry the data. You have to dereference them to pull the data. Just declare pointer, but this is uninitialized. Okay. Forgot my C++ for a second. So new std string. There. So dumb. I am so bad. There we go. Okay. Voila. We got a memory address. Okay. I forgot. So with primitives, you can kind of declare them straight out. But with in C++, not like Python. The new keyword matters. The new keyword says, I want you to assign the memory address to the heap, not to the stack. So you can also assign a pointer to the stack. Like this would assign the pointer to the stack, which might give an error. No suitable conversion from std string to. Oh, sorry. This would assign it to the stack, I think, if I didn't do that. I'm gonna have to like research that, come back to you. There's a way to assign it to the stack instead of the heap, which you might want to do if you're trying to be hyper efficient, but you don't need a lot of memory. Anyways, most of the time for using pointers, you're going to end up assigning it to the heap. So this says not in the stack where the program's running, but I want you to assign it to the extra memory address. That new keyword helps you do that. So it's create a new string object. So this is just this is not just a declaration anymore, right? So this is like basically that's the declaration. This is like create the new string object, and this is like assign that string object the value. So define the variable a as a new string object. So you're defining it, but you're also assigning that value. You've defined it and you're assigning that value a new object that you have created. So that memory of that object is now there. Now that you have the string object, a equals test, basically, and I'm not sure that'll even work. Yeah, that would give an error. So you can't assign the memory address to test, right? That doesn't make any sense. You have to dereference it, basically, which dereferencing says, that little character says, take that memory address. Now go find the object at that memory address. Pull that object and assign that object the value of string.
Mm-hmm.
Now I have that object assigned the value of string, and now I can print out the string, and std cout knows how to handle that. So, oh, sorry, that's still printing out the address. You always have to dereference it if you're going to use a pointer directly. This should be the value. There we go, test. Right, so if I don't dereference it, I get the address. If I dereference it, I get test. I know that can be really confusing, but it's a really powerful type of situation. What I'm going to do now, I'm actually going to copy this down and show you a reference instead. Okay, so instead of a pointer, I don't think I can even do this. Yeah, that's it. So I'm going to create a pointer this time, right? I'm going to define the pointer as this. But now I'm going to this new, can I do reference? I assign a reference. Usually use references with function. Let's say I'm trying to think about how I do this. I'm just going to tell ChatGPT change this to a reference. Change this to a reference. And there's a key distinction between pointers and references. Why I bring it up. That's what I was looking for. This fancy thing right there. All right, so I declared it, and then I want to make it a reference std a. Okay, so you have to declare a pointer first. So that's what we do in this line. Now I want to have a reference. Which way do they do it? It's stda. Then I'm going to create a reference to that pointer. I'll explain what that is. Reference to the pointer is s. Okay. So we'll go back to making that a. And now do s equals std string. And now I do s equals that. And now I can just do s here. S is undefined, where there's supposed to be an std string there. Okay. A lot of stuff here. So this is declaring the reference. Declare. This is just declaring a variable on the stack. This is create a reference to that string. Oh, you create. Hold on. I create a variable on the stack. Okay, so. All right, so this is declaring a variable on the stack. This is assigning, create a reference to that variable. All right, you got 2 minutes here. So here's what's happening. Reference to that variable. Then we said, now I can just assign it because I did that on the stack, so I don't need to create a new object. Assign this task. Maybe that's. I'm slow with syntax following, so it might not actually be an error here.
So you don't have to do the new.
No, I shouldn't have to because it's on the stack, not on the heap. So I'll fix this next time. But essentially, what's happening here, what I wanted to get across was that a reference is basically a pointer that cannot be changed. A reference is a pointer that cannot be changed to another memory address. So a pointer is basically a variable that points to a memory address. And what you can actually do, and I'll show this later, is you can point that pointer to a different memory address and actually forget where you stored your other data.
Mm.
But if you have a reference, basically it points to a memory address, but it says it will never not be this memory address. So you can't go and assign it to a new memory address. It's always just pointing that memory address.
Okay.
So pointers are nice, or references are nice because then you don't have to dereference them because it knows it's always going to be at that like pointer address.
Hmm.
And so what we'll end up getting to is functions can be passed by value, passed by reference, and passed by pointer. And depending on how you pass an argument in as one of those three things affects how it changes within the memory of the stack and the heap,
Mm.
which is really the fundamental, like critical piece to C++ is like pointers, references, and memory manipulation. So this was just an intro. It'll probably take a few sessions to kind of get through, and I'll try to come more prepared with like examples that work. This actually might work. Realize we're at time, but yeah, it works. But it's actually pointing to the heap. That pointer that cannot be changed, the address that cannot be changed is pointing to the heap. Or I mean the
Hmm.
stack right now, because I declared this on the stack. I think I
Yeah.
could actually declare this on the heap and the same thing would happen. So
Okay.